This video covers section 6.4, Factoring Special Products. Objective 1, factor perfect square trinomials. In order to understand the way that perfect square trinomials look, it helps us if we start with the square of a binomial. When we square a binomial, we write the binomial twice and we FOIL. We see that the f in FOIL is going to give us 4x squared. The o in FOIL is going to give us 10x. And the I in FOIL gives us another 10x. And the L in FOIL gives us plus 25. So we see that when we're done, we end up with a first term that's a perfect square. The middle term is twice the product of the 2x and 5, which is 20x. And the last term is another perfect square, which is the square of 5. So we can see that the first term is the square of the 2x. The middle term is the product of the two terms, 2x and 5. And the last term is 5 squared, or the square of the second term. So it says to square them, take twice the product of the first and the last terms and square the 5. So that is precisely what we see here. A plus b squared is a squared plus twice ab plus b squared. If we have 3a plus 5, then we square the 3a, which is 9a squared. We take twice the 3a and the 5, which gives us 30a, and square the last term 5, which gives us 25. If it's a difference, a minus b, then it's still the same form, a squared, but it's a minus 2ab plus b squared. So if we have 2p minus 3 squared, then the 2p is squared, which gives us 4p squared. The product of the 2p and 3 is 6p, and then we double that and get 12p, and then we square the 3 and get 9, but we use a minus instead. So we're going to be looking for perfect square trinomials of that form. If we see that the first and the last terms are perfect squares, like 49x squared and 4, then it hints at this being a perfect square trinomial. So we think of the 49x squared as 7x and 7x, and the 4 as being a 2 and a 2. And because it's a minus sign, we put a minus and a minus, and then we check if this negative 28 is really twice the 2 times the 7x. And so that's 14x and 14x, which is 28x. Therefore, this is a perfect square trinomial, gives us 7x minus 2 squared. Example 2. We see that the first term is 9a squared. 9a squared is the square of 3a. We see the last term is 25b squared. That's the square of 5b. Now we just have to check if the middle term is really twice those two pieces, 3a and 5b. 6 times 5 is 30 AB. So this should be 3a plus 5b times 3a plus 5b. There's the 9a squared, 15ab and another 15ab is 30. and 25b squared. So we like to write this as the square of 3a plus 5b. Example 3, factor completely x squared minus 8x plus 64. The first term, x squared, well, that's the square of x. The last term, 64, 64 is the square of 8. This looks like it could be a perfect square trinomial. When we check the middle term, it should be twice the product of those two pieces, 2 times x and 8, which is 16x, and we have an 8 there. This is a problem. And the problem is if we tried to do x minus 8 times x minus 8, we would get negative 8x minus 8x would be the negative 16x. So that means this is not equal to x minus 8 squared. This is not a perfect square trinomial. In order to try to factor it then, we would have to go back to the other techniques, and maybe there's a product of two numbers that's positive 64 that adds to negative 8. 1 and 64, we'd have to put both negatives on those. Negative 2 and negative 32, negative 4 and negative 16, and then negative 8 and negative 8. We're never going to get it. And so we would just say, since we can't factor this, we're going to write prime. That leads me to your practice problem. I encourage you to press pause in your video and work this out, and come back and press play when you're ready to see the solution worked out. Now that you've had a chance to work these out, I'll work these out with you. We look at the first term and we see it's a z squared. The last term is 64, which is 8 squared. We check the middle piece, 2 times z times 8, which is 16z. That means this is a perfect square trinomial. Because it's a minus sign, we're going to use z minus 8 and z minus 8. The middle term is negative 8z minus 8z, which is negative 16z. This tells me that it's z minus 8 squared. Letter B, the first term is 4n squared. That's the square of 2n. Last term 9 is the square of 3. In order for this to be a perfect square trinomial, that middle term has to be twice these two terms, 2 times 2n times 3, which is 12n. That means this is 2n plus 3 times 2n plus 3. We check this. 2n times 3 is 6n plus another 6n, which is 12n. So this is, in fact, a perfect square trinomial, and we write it as the square of the binomial. Letter C, the first term is a perfect square, and the last term is a perfect square. We check the middle term twice, the y and the 6, which gives us 12y, but we wanted 10y. It's not a perfect square trinomial then. So we would have to go back to the old techniques to see if maybe it factors using two different numbers. Product of two numbers, that's 36, that adds to 10. 1 and 36 is way too big. 2 and 18 is 20. 3 and 12 is 15. 4 and 9 is 13. And 6 and 6 is 12. So the smallest or the closest we can get to 10 is 12, but nothing gives us 10. When we can't factor something, we write prime polynomial. So again, just because it's not a perfect square doesn't mean that it doesn't factor. You have to take it a step further and see if maybe you can factor it. Example 3. Nothing looks to be like a perfect square anywhere in that first and last term. But then I recognize that there is a GCF. It looks like I can factor out a 2a from all of the terms. When I take a 2a off of the first term, I'm left with 25a squared. When I factor off a 2a from the second term, I'm left with 40a. When I take a 2a off of the last term, I'm left with 16. Now what remains is a first term that's a perfect square. 25a squared is 5a squared. 16 is 4 squared, and then we check 2 times those two terms to see if it gives us the 40. 2 times 5 is 10, times 4 is 40a. So this is a perfect square trinomial, so we write it as 5a plus 4 and 5a plus 4. Just want to make one other check, and that's 5a times 4 is 20a, 4 times 5 is 20a, and 20a plus 20a is 40a. So we write this up as 2a times 5a plus 4 squared. This concludes the video for section 6.4, Factoring Special Products, Objective 1, Factor Perfect Square Trinomials.